we have an all-new battery pack. And then something we're really proud of is the new carbon-sleeved rotors for the motor. So this is the first time that...
Have you ever stopped to imagine what might happen if one company, just a single company, suddenly pushed itself far beyond everything the electric vehicle industry had ever achieved? Not merely one step ahead, not simply one generation ahead, but so dramatically far in front that every other competitor would have to stop and wonder, who the hell are we actually competing against? A few weeks ago, when Elon Musk stepped onto the stage and revealed Tesla's newest electric motor, most people assumed it would be another routine technology presentation. A new product announcement, several impressive specifications, a round of applause, and then life would return to normal. Except it did not. This time, something was genuinely different. Because what Tesla has unveiled is not merely a more powerful or lighter electric motor. It represents a fundamental change in the way we think about what an electric motor is, what it is capable of achieving, and how far its limits can be pushed. With a carbon fiber sleeve surrounding the rotor, rotational speeds exceeding 20,000 revolutions per minute, and the ability to launch a vehicle from 0 to 60 miles per hour in under 2 seconds, Tesla has effectively pushed the entire electric vehicle industry onto an entirely different level. And many competitors may not even fully understand what has happened yet. But here's the part that deserves even more attention. Tesla is not keeping the secret locked away. The company opened its patents for everyone to examine. Any automaker anywhere in the world can study the designs, analyze the ideas, and attempt to reproduce them. So why does that not destroy Tesla's advantage? Why can someone know the recipe perfectly and still fail to make the same dish? And perhaps more importantly, what could all of this mean for millions of people considering the purchase of an electric vehicle over the coming years? Can rival brands realistically catch Tesla? Or are we watching the beginning of a period in which Tesla becomes the undisputed leader? Those are exactly the questions we are going to examine in today's video. And I promise you, the deeper we dig into this story, the more fascinating it becomes. Before we get started, if you enjoy detailed analysis videos like this, videos that go beyond simply reporting headlines and instead explain why something matters and how it could change the future, hit the subscribe button right now. Elon Musk turns an impossible dream into a worldwide threat. To understand why Tesla's newest motor is creating such a strong reaction, we need to go back a little further in time. Not merely a few years, nearly 20 years. In 2003, when two young engineers named Martin Eberhard and Mark Tarpenning established Tesla Motors in San Carlos, California, much of the automotive industry treated the idea almost like a joke. Electric cars at the time, when they existed at all, often resembled golf carts with windows attached. They had little real power, barely useful driving range, and almost nobody genuinely wanted to take one onto a highway. The idea that electric vehicles might someday challenge gasoline cars in performance, styling, and driving excitement was widely rejected by industry experts. Hardly anyone believed it. Not one major automaker was prepared to seriously bet its future on that idea. Then Elon Musk entered the picture. In 2004, when Musk invested in Tesla and became the company's largest shareholder, he brought much more than funding. He introduced an entirely different philosophy about what an electric vehicle could become. Not transportation designed only for environmental activists, not an economy car intended simply to save fuel costs. In Musk's view, an electric vehicle needed to become the most beautiful, fastest, and most exciting machine someone had ever driven. In 2008, Tesla introduced its first Roadster. Built around a Lotus chassis, the car could outperform many gasoline-powered sports cars in its category. And it demonstrated one basic yet revolutionary idea. An electric motor could deliver serious performance. Not theoretical power written on a specification sheet. Actual power you could physically feel when you pressed the accelerator and your body was pushed firmly into the seat. Then came the Model S in 2012. A luxury sedan equipped with an enormous touchscreen, over-the-air software updates, and enough acceleration to make BMW and Mercedes pay very close attention. After that came the Model X, with its distinctive falcon wing doors. Then came the more affordable Model 3, which opened Tesla to the mainstream market. Then the Model Y. Then the Cybertruck, looking almost like a damaged spacecraft that somehow landed on Earth. Every new Tesla product forced the rest of the industry to respond. Traditional automakers began rushing to introduce electric vehicles of their own. Ford launched the Mustang Mach-E. GM committed billions of dollars to its Ultium platform. Volkswagen introduced its ID family. Hyundai and Kia suddenly emerged as serious competitors in the EV category. At that point, many analysts began arguing that Tesla had already reached its peak, that its best years were behind it, that once the traditional giants finally entered the electric vehicle race, Tesla would stop being special. They were mistaken. Because while the rest of the industry was struggling to catch up with what Tesla had already created, Tesla itself was quietly preparing another major leap forward. A leap almost nobody in the industry had truly anticipated. But to understand why that next leap could matter so much, we first have to examine the center of the entire story, inside the motor that could change everything. When Elon Musk walked onto the stage and introduced the new Plaid motor featuring a carbon sleeve, many people probably had the same first thought. That sounds impressive, but is it really that different? The answer is yes, and the difference extends far deeper than anything visible from the outside. Let's begin with the heart of every electric vehicle, the rotor, the spinning component inside the motor responsible for converting electrical energy into mechanical movement. In many electric motors today, rotors are built primarily from copper and steel alloys. Those materials have performed reliably for decades, but they also face an unmistakable physical limitation. As rotational speed increases, the centrifugal forces acting on the rotor rise dramatically. Eventually, those forces reach a point where the material starts to deform. Heat generation increases, mechanical precision decreases, and the entire motor gradually becomes less efficient at exactly the moment when maximum performance is required. Tesla approached this problem with a solution that sounds remarkably simple in theory, but is extraordinarily difficult to execute correctly: surrounding the rotor with carbon fiber. Carbon fiber, the same type of material commonly seen in Formula One cars, advanced aircraft, and space hardware, offers a significantly better stiffness-to-weight ratio than conventional steel. It weighs less, remains more rigid, and most importantly, handles tensile forces at extreme rotational speeds exceptionally well. When Tesla winds this carbon layer tightly around the rotor, it applies an outside compressive force, often described as preload, that helps keep the internal rotor structure stable even while spinning at enormous speeds. The result? Tesla's rotor can exceed 20,000 revolutions per minute, a level that most traditional electric motors rarely approach. And that extraordinary rotational speed contributes directly to the power and brutal acceleration drivers experience from behind the steering wheel. That is one major reason why the Model S Plaid can accelerate to 60 miles per hour in less than 2 seconds. Until fairly recently, numbers like that were associated almost exclusively with million-dollar hypercars from companies such as Bugatti or Koenigsegg. Tesla effectively placed that level of performance inside a practical family sedan. But outright speed represents only part of the story. The more meaningful advantage may actually be efficiency. Because the rotor is lighter, the motor requires less energy simply to spin itself. That means the same amount of electrical energy stored in the battery can potentially take the vehicle farther. It means the cooling system does not need to work as aggressively. It can also reduce stress on the battery and contribute to longer battery life. Together, these improvements reinforce one another and create a positive cycle: greater motor efficiency, improved battery durability, longer driving range, and lower operating expenses. There is also another issue that is often overlooked whenever people discuss electric vehicle performance: thermal stability. In conventional electric motors, heat is one of the greatest enemies. As temperatures rise, metallic components expand at different rates, potentially creating microscopic imbalances inside the motor. Over long periods, those imbalances can contribute to wear, vibration, and declining performance. Tesla's carbon sleeve behaves differently. Its expansion characteristics allow it to maintain strong compressive pressure across changing temperatures, helping the rotor remain stable under demanding operating conditions. Put another way, this is not simply the fastest electric motor Tesla has ever produced. It may also be among the company's most stable, durable, and efficient motor designs. All of those advantages are packed into the same architecture, and while the concept may sound surprisingly straightforward, that seemingly small design detail could ultimately be the feature that changes the entire game. The real secret is hiding where almost nobody looks. Now we reach the part that becomes genuinely fascinating once you understand what is happening. Wrapping carbon fiber around a metal rotor might not sound especially difficult when described in a sentence. In actual manufacturing, however, it becomes one of the most demanding engineering problems Tesla has ever attempted to solve. Why? Because carbon fiber and metal, especially materials such as the copper and steel found within the rotor, have very different thermal expansion properties. Put more simply, as temperature changes, these materials expand and contract at different rates. If carbon fiber were simply wrapped around the rotor without extremely accurate engineering calculations, the intense temperatures generated during operation could cause the carbon layer to separate, fracture, or even create a severe imbalance while the rotor is spinning at 20,000 revolutions per minute. And you can imagine the consequences of that happening inside a high-powered electric motor. Tesla therefore had to develop an entirely new robotic manufacturing system from the ground up, controlled with artificial intelligence and capable of applying the carbon fiber at micrometer-level accuracy. Not millimeter precision, micrometer precision, equivalent to 1,000th of a millimeter. The system has to control multiple variables simultaneously: carbon fiber tension throughout the winding process, surrounding temperature, wrapping speed, the precise angle at which the fiber is placed, and then the completed rotor must be checked by laser sensors to confirm that virtually no deviation exists. Every individual rotor is inspected before it is finally installed inside a motor. And this brings us to the most important point. Tesla patented the carbon sleeve technology, and then made the patents available to the rest of the world. Anyone can inspect the design. Any company can study exactly how the concept works. But knowing the design is not the same as possessing the manufacturing machinery. You can know the secret and still be unable to reproduce the result. You do not automatically have the artificial intelligence system trained through thousands of experiments to determine the exact amount of fiber tension required. You do not possess the quality control system that has been refined through years of production experience. And even if you somehow obtained all of those capabilities, you would still face the challenge of integrating the entire process into a manufacturing line capable of producing tens of thousands of motors every month. That is one of the cleverest aspects of Tesla's strategy. Opening patents is not necessarily an act of generosity. In some ways, it is a demonstration of the manufacturing gap. Tesla is effectively telling competitors, "We have moved so far ahead that even if you understand exactly what we are doing, reproducing it at scale will still be extremely difficult." But regardless of how impressive any technology might be, it ultimately means very little unless it can be manufactured economically and at enormous scale. The problems Tesla would rather you forget. Of course, the story is not perfect. And if we talk only about Tesla's strengths while ignoring the genuine risks, then this would not be serious analysis. So we need to examine the challenges the company still faces. First, manufacturing cost. Producing a carbon fiber sleeve with micrometer-level accuracy is expensive. Every rotor needs valuable machine time, extensive quality inspection, and costly materials. Although Tesla continues expanding production capacity, each plaid motor still costs considerably more to manufacture than a conventional electric motor. That immediately raises an important question. Can Tesla eventually bring this technology into mainstream vehicles such as the Model 3 and Model Y? Or will carbon sleeve motors remain limited to expensive performance models for years to come? Second, financial pressure. During 2024, Tesla conducted major layoffs, while investors increasingly questioned shrinking profit margins as the price war against Chinese electric vehicle manufacturers became more aggressive. BYD, SAIC, and NIO are no longer minor startups trying to establish themselves. These companies are manufacturing enormous numbers of vehicles at significantly lower costs while rapidly expanding into markets outside China. And in a price war, superior engineering does not automatically guarantee victory. Third, Tesla remains unusually dependent on one individual. Elon Musk is undoubtedly a brilliant marketer and has been the strategic driving force behind many of Tesla's biggest breakthroughs. But the company's extremely close association with him also creates a significant risk. Musk's controversies on social media, polarizing public statements, and repeated promises that have not arrived according to original schedules can all influence consumer confidence in Tesla. And for buyers aged 45 and older, people with enough life experience to be less easily carried away by excitement, trust often matters considerably more than acceleration numbers. Fourth, charging infrastructure. Tesla's supercharger network remains one of the company's strongest competitive advantages in the United States. But as Tesla increasingly allows vehicles from competing manufacturers to access those superchargers, the network becomes less exclusive. Meanwhile, range anxiety continues to remain a powerful psychological obstacle for buyers living in states where public charging networks are still relatively sparse. And fifth, uncertainty surrounding autonomous driving. Tesla has promised full self-driving capabilities for many years. The system has undoubtedly made substantial technological progress, but it still has not reached the level Elon Musk once suggested would arrive. That leaves a persistent gap between expectations and reality, and repeated gaps of this kind can weaken credibility over time. None of these challenges cancel out what Tesla has accomplished with the Plaid motor, but they remind us of an important truth about the real business world. Having the most advanced technology does not automatically mean winning the market. Many different pieces must come together at exactly the right time, and this is where the competitive race becomes even more intense, because Tesla is far from the only company fighting to control the future. The competitors that refuse to surrender. When Tesla revealed the Plaid motor and its carbon-sleeved rotor, competitors reacted in very different ways. Some said almost nothing. Others attempted to minimize the importance of the announcement, and some quietly increased the pace of development inside their own engineering laboratories. So let's examine them one by one. Lucid Motors may be Tesla's most dangerous rival when judged purely from an engineering perspective. The Lucid Air Grand Touring Performance offers more than 500 miles of driving range, a number that the Tesla Model S still has not achieved, while Lucid's drivetrain demonstrates an impressive level of engineering sophistication. But Lucid faces a major weakness: sales volume. The company builds and sells only a relatively small number of vehicles each year, with most of its business concentrated in the ultra-luxury market. That represents a niche, not a mass-market revolution. And without enough revenue coming in from high-volume vehicle sales, Lucid does not have unlimited resources to develop future-generation electric motors at a scale capable of matching Tesla. Rivian is pursuing a different strategy: electric pickup trucks and SUVs aimed primarily at customers who enjoy an outdoor lifestyle. The company has attractive designs, a loyal customer community, and important financial backing from Amazon. But when it comes purely to motor technology, Rivian continues to rely on a relatively conventional architecture, and the technical gap with Tesla risks becoming larger as each new generation arrives. Ford represents perhaps the most interesting example among traditional American automakers. The F-150 Lightning achieved respectable sales and demonstrated that American consumers are willing to purchase electric pickup trucks. But Ford still relies heavily on outside suppliers for batteries and electric motor components, while the company has repeatedly reduced electric vehicle production targets after costs became difficult to control. Because Ford's business remains divided between gasoline-powered vehicles and electric models, it cannot commit everything to next-generation electric motor development in quite the same way Tesla can. GM has invested nearly $35 billion into electrification, but its Ultium platform, once presented as the technological foundation of the company's future, has experienced delays and difficulties during real-world deployment. Models such as the Cadillac Lyriq and Chevrolet Equinox EV are capable vehicles, but they have not created the kind of technological wow moment associated with Tesla's latest motor. And then there is BYD, arguably the competitor Tesla needs to monitor more carefully than anyone else. This Chinese manufacturer has surpassed Tesla in total global electric vehicle sales. BYD operates one of the most vertically integrated supply chains in the industry, producing its own batteries, semiconductors, and numerous other critical components. Its manufacturing costs are substantially lower, and the company is expanding aggressively across Europe, Latin America, and Southeast Asia. Yet BYD still faces an important weakness. Its brand recognition and software ecosystem remain relatively limited in the United States. American consumers, particularly those aged 45 and older, often place more trust in brands they already know than in unfamiliar names entering the market for the first time. And until BYD can truly enter the United States in significant numbers, something currently complicated by tariffs and broader trade policy, Tesla continues to enjoy a powerful home market advantage. The central point is this: no competitor currently challenges Tesla across every category simultaneously. Lucid possesses exceptional engineering but lacks scale. BYD has massive scale but limited brand strength in America. Ford and GM possess familiar brands but do not currently match Tesla in the other areas. Tesla, meanwhile, combines scale, brand, software, manufacturing expertise, charging infrastructure, and now an electric motor that competitors cannot easily duplicate. So we eventually arrive at the biggest question of all. Is this technology genuinely powerful enough to reshape the future? When an electric motor becomes bigger than the car industry. This is where the story expands into something far larger. Something that reaches beyond one vehicle, one brand, or even one automotive competition. During the presentation of Tesla's Plaid motor, Elon Musk made a comment that many people barely noticed because everyone was concentrating on the spectacular performance numbers. Musk suggested that an electric motor with this kind of power-to-weight ratio, thermal stability, and ability to maintain extremely high rotational speeds for long periods could have applications far beyond automobiles. Consider electric aviation. One of the biggest barriers facing electric aircraft is the propulsion system itself. An aviation motor must be lightweight enough that it does not add excessive mass, while also being powerful, efficient, and reliable enough to meet extremely demanding safety requirements. Numerous startups are currently developing electric vertical takeoff and landing aircraft, yet almost all of them encounter a similar engineering challenge. Existing motors are often either too heavy or not sufficiently efficient throughout the wide operating ranges required by aviation. Tesla's carbon-sleeved Plaid motor could potentially offer an answer. It is lightweight, extremely powerful, thermally stable, and capable of operating at very high revolutions per minute for extended periods without suffering significant performance loss. Those are precisely the characteristics electric aviation companies are searching for. Tesla has not officially announced plans to license the Plaid motor for aircraft applications, but some of the indirect possibilities are difficult to ignore. And if Tesla ever chooses that path, the company would no longer function only as an automobile manufacturer. It could become a major hardware supplier for a much broader energy transformation. Then consider energy infrastructure. Wind turbines, industrial pumping systems, large energy installations. All of these applications depend on efficient electric motors capable of surviving demanding operating environments. If Tesla manages to mass-produce Plaid-style motors at progressively lower costs as manufacturing volume rises, it could eventually become an electric motor supplier across multiple parts of the clean energy economy, from automobiles to aircraft to industrial systems and the electrical grid. This is not some impossible science fiction scenario. It would be a logical extension for a company that already operates gigafactories across 3 continents, produces megapack battery systems for large electricity networks, and sells Powerwall energy storage systems connected with solar power for households around the world. Tesla is gradually becoming more than an electric vehicle manufacturer. It is positioning itself as an energy and transportation platform for the 21st century. And what are traditional automotive competitors doing? Most of them are concentrating on building a competitive electric car. Tesla is attempting to build technology for an entire world that eventually moves away from fossil fuels. Those ambitions represent 2 very different games in terms of both scale and long-term vision. And the Roadster 2.0, Tesla's long-promised electric sports car that has experienced repeated delays, could eventually become the ultimate demonstration of everything this motor technology is capable of achieving. If the car finally launches with the performance Tesla has promised, acceleration from 0 to 60 miles per hour in under 1 second, more than 600 miles of range, and full integration of Tesla's newest motor technology, then it will represent far more than another extremely fast automobile. It could become one of the strongest technological statements ever made by a car company. The competition is certainly not finished, but once again, Tesla appears determined to rewrite the rules of the competition itself. So we have now traveled through a long story, from Tesla's original Roadster in 2008 all the way to an electric motor today whose rotor is wrapped in carbon fiber with micrometer-level manufacturing precision. But I want to stop for a moment and talk directly about what may be the most important lesson from everything we have discussed. Tesla's Plaid motor technology is real. Its performance figures are real. And the engineering advantage Tesla currently holds over many competitors in electric motor development, at least right now, is also real. But technological history repeatedly reminds us that having the superior engineering solution does not always determine who wins commercially. Betamax was technically superior to VHS in several respects, yet VHS became the winner. BlackBerry offered a physical keyboard that many people considered better than early touchscreen typing, yet the iPhone completely transformed the smartphone industry. Nokia controlled the global mobile phone market for years, and then its dominance nearly disappeared in an astonishingly short period of time. The electric vehicle industry is still being formed. Consumers are becoming increasingly knowledgeable. Government policies supporting electric vehicles can change rapidly. Battery costs continue falling, which can reduce advantages that once looked permanent. And in an increasingly complicated geopolitical environment, decisions surrounding tariffs, trade rules, and supply chains can reshape competition in ways that almost nobody can confidently predict. So yes, Tesla has accomplished something highly impressive with its carbon-sleeved Plaid motor. But does that truly represent the end of the electric vehicle industry as we currently know it? Are competitors genuinely incapable of catching Tesla? Or are engineers inside those companies quietly developing breakthroughs of their own that the public has not seen yet? The truth is, I do not know. And anyone who tells you with complete confidence that they already know exactly how this competition will end should probably be viewed with some skepticism. What I do know is this. Everything happening across the electric vehicle industry right now, the aggressive competition, constant technical breakthroughs, intense price wars, and massive race to build infrastructure, is actively shaping the future of transportation around the world. What unfolds during the next 3 to 5 years could determine what this entire industry looks like for decades afterward. So what do you think? Has Tesla genuinely ended the game with this new electric motor? Or can competitors, from Lucid and BYD to companies most of us may not even know yet, still deliver unexpected breakthroughs of their own? I would genuinely like to hear your opinion. Leave a comment below, especially if you currently own a Tesla or are seriously considering buying an electric vehicle. Tell us what you really think. Those first-hand perspectives are often the most valuable. If this video helped you discover something new about the electric vehicle revolution, hit the like button to help the video reach more people. And if you want to continue following detailed analysis like this, not only about Tesla, but about the much larger picture of technology, transportation, and energy that is reshaping the world? Subscribe to the channel